the last assignment also, that we will try to discuss. So there are actually two types of file format, row-based and the column-based file format. Traditionally, whatever the file formats we were using before the big data era, before the distributed computing, that was kind of in a row-based file formats. Okay, so we can categorize mainly into them into the two only, row-oriented storage and the column-oriented storage. Okay, so it's as a name itself, it is suggesting that what kind of file format it is going to be. So row means it is stored row by row. Okay, one row at a time. Okay, whereas the column oriented, the stores the data in a column wise, so one column. Okay, so how it is stored on the disk, I'll explain. Okay, so from here, this is the sample data. You can see that there are 5 rows. Okay, so whenever we actually store this data into the traditional row oriented file format, it will be entire row, it will be stored on the somewhere, on the storage layer. Okay, okay, so while the column, then the employee ID, employee name, employee last name, joining date, all these are the different 4 columns. Whenever we are going to store the column in the column oriented fashion, it will be stored in the disk itself in the column fashion. So, okay, in the next slide, anyway, I'm going to share how it is going to work. Before that, we should understand how the hard disk drive actually stores our data. Okay, so because of we come up, we actually had we have built the operating system and whatever the file system. Okay, so file format that are on your operating system, like in FAT, NTFS, might you have heard about it. Like in, these are the famous file formats for the Windows, FAT and NTFS. If you go about the Linux, ext3, ext4, those are the file format for the Linux. So every operating system has their own storage. Okay, storage format. Okay, and whatever the data is we are actually storing on the operating system, that stores on your hard disk drive. But we should understand that how the hard disk drive is actually built. Okay, so if you're not aware about how the hard disk works, it has a platters. Okay, so platters are the kind of your disk kind of disk, which are multiple disks based on the how what is the size of your hard disk drive, and it has a tracks and the sectors. Okay, so how the data is read on the your hard disk drive. Okay, so there is a read write head, you can see over here. Okay, you can see that this is the read write head, actually moves back and forth like this, it continuously moves and it reads the data from the desired location. This happens really quickly, really fastly. Okay, and multiple times, from the top and the bottom of the disk data is written. Okay, so this read write header is like an, there are multiple what you can say the read write headers in this on each disk actually. So there are multiple disks and the multiple read write heads are there. Okay, but that's how the data is actually read. The disk moves, along with that the read write head also moves, and that's how the data is actually read. But we have to understand that the sector size, okay, the sector size of your disk is really small. It's in it may be in the kbs. Okay, it could be kbs. Okay, we will take a hypothetical imagination that the each sector is in the kbs only. So you can understand that, let's say if you ask, if you're willing to read the one GB of data from the disk. Okay, so how much work your disk need to be done. Okay, so because each time it has to move to the all the sectors, and then the data actually reads. And whenever your operating system writes the data onto your disk, it's not written in the consecutive location. Okay, it's never going to, like, it will be place the data randomly on your disk. Okay, there are a lot of factors why it is done in why not, but we will not jump into the operating system file formats, because that's an altogether different discussion. But I'll actually giving the kind of background or history why we have come up with the modern file system, which are actually virtual file system. These are the not actual file system. These are the virtual file system, like in Hadoop distributed file system or whatever, modern, like in Databricks file system. You have what you can say object based file format like an S3, ADLS. All these other different file format kind of things are there. So as as the as in this slide is actually explain about, these are the operations which are operations are expensive. So sometimes, reading the unnecessary data is really expensive. Okay, reading the fragmented data is also expensive. Every small fragment reading is expensive, because you have to collect the small fragment, and then the actual data is an entire whole data is actually you can read it. Okay, random seek is what you have to move this read write head back and forth. That is what we call it as random seeks will be there. Okay, so all these are the kind of things which are actually costly operations, and that's why we have to minimize our read write head movement so that we can read the data really quickly. So let's this is what the one of the video which has actually explained how the hard disk is actually there, so you can understand why we come up with the.
The hard drive has been the main storage device in computers for decades now. Do you ever wonder what's on the inside? Hard drives are sealed so that no dust can get inside.
AP systems, okay, whatever Databricks, whatever the big data, all these things we are learning because of we are going to do OLAP, OLAP kind of requirement. Okay, so we are doing the analytics. Analytics, we don't need everything in the analytics. We need a few things from the raw data, or we try to only project or select few columns from the data. So that's the main requirement of an analytical process. So here also, keeping that in the mind, they have come up with the row based file format. Here in the column oriented or column based file format, what is happened, entire row is actually stored as a single, what you can say, as a single block or single thing into the R disk. Okay, so what is the drawback of that? Let's say I want only the first name of an employee. What unnecessary information I'll be reading? I'll be reading entire thing, because date of birth, his last name, okay, employee ID also. So those are not requested by me, because I'm doing the analysis. I need a first name, or let's say first name and his joining date. Okay, so in that case, what happen? Unnecessary data is actually we are reading. So that is a drawback with the row oriented file format. That's why we actually moving to the column oriented file format in the in OLAP systems. Okay, these are the typically best for the OLTP system, row based, because those have been built for that thing only, like an OLTP. OLTP has a multiple write, multiple read things. Okay, in the case of OLAP, it's kind of operational where we are writing once and reading many times. That is what the analysis. Okay, so bring the historical data, put it inside your let's say warehouse, and read it many times as as per my requirement. Okay, as per my analysis needs. So write once and read many times. That is the operation of OLEP, whereas the OLTP means like write many times and read many times. Okay, and those systems are actually different. Okay, so we will we move to the column oriented file format, because they stores the things like differently, as an co- as in a single column is actually stored on the disk space. Okay, so here we can see that employee ID, employee name, last name, first name, last name, and joining dates are stored differently on the disk. Okay, so this is how the column oriented storage looks like. Okay, so now if I'm going to read the first name of an employee, this is going to be fast, or the previous one is going to be fast. Obviously this is going to be fast, because I need what I need, I need all the first name of this. So from here I'll get it all the first name. I don't have to go for the other things, other locations to get the data. So that's the benefit of column oriented storage. So what are the different, they there are different file formats. Okay, this is what the how the column oriented storage looks like. But there are multiple, what you can say, the file format. Let's understand this. What are the row based and the column based file format available in the market? So Parquet is one of the famous, which we have been using. Okay, so Delta is there, ORC is there. Okay, uh, Apache Hive, Cassandra actually uses this technology only. Okay, Redshift actually uses same, BigQuery, Snowflake. Okay, HBase, HBase actually uses your underlying HDFS only, and on top of that they are actually using the Parquet. So Apache Hudi, Iceberg, these are the modern kind of file format. But mostly with the Spark you will find the Parquet, and with the Databricks, okay, Delta is there also with the Azure, and that Delta file format is also famous. But whereas if you compare, if you think about the row-based file format, that there is a CSV, JSON, XML, Avro, all your relational database like MySQL or SQL Server, they actually use this row-based file format. Then you got all these different NoSQL database like in MongoDB and Redis. They also use this the row-based file format. So as per your need, okay, if you're working with the requirement, then you have to go with the column based. If you're working with the OLTP like a kind of requirement, you have to go with the traditional file system. Okay, so that's the main difference, and that's why we are actually using the Parquet, because we are doing the analysis. So whatever the data, raw data, maybe coming as a traditional row-based file format, but we need to convert them into the column-oriented file format, so that it's going to be really fast, and it will be going to be optimized. So what are the another benefit the Parquet file format and all this column-oriented file format they comes with the compression. Okay, so we can compress the data like we do the zip on our flat files. Similarly, we can compress the Parquet. Okay, so we can define that which type of compression we required. Okay, by default it comes with its gzip and the snappy codec. Those are the some of the compression techniques that actually uses with the Parquet. So that is also benefit using the Parquet file format. Anyway, we will jump into the in detail Parquet file format, but I just wanted to highlight over here how the Parquet file format looks like, okay, and how it is actually comes in. What is the benefit of a Parquet file format? You can see this is what the actual Parquet file format, how it is actually storing the data in the format. Okay, so we will now deep dive into this, because altogether this discussion like only trying to understand the Parquet file format, it will take some half hour, more than half hour actually. When we actually come across the optimization techniques, at that time I can explain these things in detail, so that at that time you will be understanding uh, why and how the Parquet file format looks inside, and what is the benefit of that. Okay, so there are this concept of the row groups, there is a concept of a page. Okay, so what is a row group, how the particular row group is actually storing the data in the columnar fashion and all that. Okay, so I'll not do deep dive into this, but once we come across the optimized techniques, we will try to understand the Parquet file format. And anyway, we will not discussing all the file format, because learning all those file format will be take time. But in the market, the Parquet is very famous with the Spark, so you will be using the Spark and Delta. So we will discuss about the Parquet and Delta. RC or RC are kind of those are not used nowadays, because this Parquet and the Delta have a more benefit than this RC or RC file format. So any doubt into this file format? Then before moving to our labs today, I think we are good. So let's start with the lab actually. So you understood that why we're actually using the column-oriented file format. Are you following?
Yeah.
Okay, fine. So let's open our Databricks now. So before that, let me just download these things. You must have downloaded all these things. Okay, so just try to run them before we get started, so that you will be on the same page.
One
Yeah.
second, Ravindra. Let me provide the package to the team,
Okay, fine.
and then we'll start. Give me 2 minutes.
Fine. Meanwhile, if you have any doubt, you can ask.
Hello, Chandri. Yes, Revati. Yeah, could you share the file for me also? Because I'll keep that zip in this chat box only so that everyone can access it. Okay, thanks. Yeah.